Hello and good evening, everyone. Welcome to all tech enthusiasts joining us for the third talk in our DevFest 2024 DevFest Talk series. My name is Rabhi Munyahibat Rahman, and I am a third year computer science engineering student at Easy Algiers. I'll be your host for this session. Today's talk will take us through an exciting journey, exploring the differences between data science as taught in universities and how it's applied in real world industries, particularly in telecom. Our speaker for this session is Benaissa Mohamed Fayçal, an experienced full-stack machine learning engineer. He brings a wealth of knowledge from his work in the computer software industry. He's skilled in areas like data science, computer vision, machine learning, and web development with Django. Benaissa also holds a master's degree in artificial intelligence from Université des Sciences et de la Technologie Houari Boumediene. Welcome among us, Benaissa Mohamed Faisal. I hope you're as excited as we are to be delivering this high quality talk. Without further ado, let's dive into today's talk. You may now start, Benaissa Mohamed Faisal.
Can you hear me? Hello, Assalamu alaikum. With you is Fayçal Benaissa. I'm a data scientist and advanced analytics engineer at GZ. Before GZ, I worked in many domains before. So I think I have basic knowledge that I can share with you, and hopefully it will be enriching for you, and it will be useful information for you. So the motivation of this talk came from my vision, or let's say my intuition when I was a student about data science. I used to see a data science in a particular way, but when I went into the industry and I started getting my hands dirty in the field of data science, I had a completely different vision. And I also noticed that students and interns that came to me for guidance, they have the same vision that I had when I used to be a student. So our talk today is geared towards this goal. So we will try to have a real world intuition and frame data science as it is in the real world. So this is the agenda for today. We'll start by understanding data science and what's needed. What is it needed for? Then we'll dive deeper into real world use cases, especially in telecom industry. Then we'll see how data science is done, and then the challenges beyond the classroom. So as you may know, or I'm sure many of you heard this information before, but humanity, since the dawn of humankind, since God created the heaven and the earth, until around 2003, humanity created around 5 exabytes of data. This is a huge amount of data to wrap our head around, but currently, we are generating the humanity is generating around the same amount of data every 2 days. So this boom in data shifted our vision about the world and made philosophies and ways of thinking such as deism exist. Deism is basically a way of thinking that centers data and algorithms around the decision making mechanism. So it allows us to take decisions and interact with the real world based on data that we can measure. So everything we can measure is everything we can manage. So in this ocean of data, well, in this ocean of data, we have a lot of emerging, let's say, disciplines such as data engineering, data analytics, and a lot of helper disciplines that made the management of the sea and the ocean of data possible. And one of the most important disciplines is data science. So what is data science? So basically, data science is in the sea of and in this ocean of data. Data science is a discipline that allows us to basically hunt for treasures. It allows us to leverage many other disciplines such as data engineering, visualization, computer science, and statistics, and especially mathematics, in order to extract valuable insights from large amounts of data, whether the data is structured or unstructured data, in order to help us better manage our systems, take better decisions, automate our systems as well. So I would want you to take a moment and think about the data scientist. So I'm sure that many of you will probably think that a data scientist is someone who is have a high level of technicity, and who is probably someone who masters Python, all the technologies. He is always on the bleeding edge of technology and masters a lot of statistics. But there is more to that. In the real world, data scientists need to have skills and the curiosity of a 5 years old kid, and the emotional intelligence of a psychologist. So why do we need this? Why do we need all of this tools and all of these skills? Why do we need data science? So basically, data science come into play in many industries, especially where data is involved. So the basic need for data science and machine learning is to take better decisions and to take informed decisions about the real world. So with the amounts of data available, we can like analyze this data and probably make predictive models that inform us about the future of our company. Or we can also take decisions about the present. Maybe we want to detect anomalies in our systems. Maybe we want to detect certain patterns that are not apparent, that the human being or the human agent might take a lot of time to wrap his head around it or discover it. Also, data science come into play when optimizing processes and automating them. So many processes generate a lot of data because of the way they are measured. So every process, for example, in a telecom industry, a process of managing a phone call generates a lot of data, whether it is about the quality of the network during the call, maybe it can be the length of the call, the technology used during the call, because a company can have many technologies put into action. So data science can leverage all of these data sources to make decisions about the present, whether for example, we can optimize our network to have better performance, automate certain tasks that some human agent are doing, and it takes them a lot of time and error to achieve. So this is one of the use cases of data science. Another use case is predictive analytics. So certainly, we want to understand the future, what's going to happen in the future based on the past, based on the patterns that were present in the past, in order to predict what's going to happen in the future. And this will help us to take better decisions. If we are, for example, predicting our revenue to drop next month, obviously we need to take actions to better make the revenue grow and go in the right direction. Also, with the large amount and with big data, large amounts of data generated every day, we need to understand this data, because there is no human being that can grasp all of this terabytes of data in his head and make conclusions of it, can make it draw insights. So data science is leveraged to understand this data, to understand the patterns, and discover the hidden insights in order to be well informed about our business or about any task that we want to achieve. So data science have been we at GZ have been leveraging data science for many years now to solve many of our problems, and these problems are real world problems that we proposed real solutions to through data science. So as you may know, in the telecom industry, the market is very saturated, where obtaining a new client is a very difficult task. So it can be really really difficult to grow the client base, because if you want new clients, we need to either steal clients from our competitors, or wait for new person to be born and grow up and buy a new SIM card. And that's the only channels of getting to customers. So the second channel we don't have any control about, because it's organic, it's just how society works. But the first channel, we have control of. We can draw the attention of some clients that are subscribed with our competitor services into our uh, network, basically. But this is very problematic, because we don't measure any data about our competitors clients. And here, the first step to grow our client base is to make it stable and to not lose clients. And here, where we built a model, churn prediction model, that uses advanced analytics and uses interconnection between different machine learning and data science models in order to predict the churn probability of a client. So a client can exert certain behavior that we can capture with our machine learning model, and based on that behavior, the models can decide whether this client is about to churn, meaning about to leave our service and go for another competitor service, or not. This churn prediction algorithm have been developed over the years, and we have been constantly building upon it until it reached the level of maturity we have now. So currently we have around like 6 models that are working together in order to predict churn. So churn is a very, very important and very important use case in our business. A second algorithm or machine learning use case that we leveraged at GZ is social network analysis, where we analyze the connection and the communication between people in our network to identify subnetworks. So let's have, for example, a person who calls his family and his friends. So we can say that his own network is a subnetwork of our global network that he communicates with. So we are interested to analyze his networks and identify leaders in this network, in his network, because when we identify a leader, it can be valuable information for us to keep the whole network with us, and to prevent the whole network from having bad experience and leaving GZ. Because according to our definition, a leader whose satisfaction has his satisfaction has impact on the other members of the network satisfaction. So for example, let's have an example of a father in a family. The father can have a GZ SIM card, and he can be satisfied with the service, and he can call all of his sons and his wife and his daughters using his GZ SIM card. But if he is unsatisfied about this service, he will change to a competitor SIM card, and this will lead all the family members to change their SIM cards in order to be able to communicate in a low cost way with their father. So the social network analysis allow us to identify each network in our global network, then identify the leaders and make sure that the leaders are satisfied through marketing campaigns and through direct targeting, through phone calls and customer care and customized customer care. Also, we have sentiment analysis, where it's an NLP task, where we try to understand client feedbacks, whether if it's from like testimonials or feedback on social media. And this was a very difficult task, because we had comments in many languages, mainly in French and in Arabic and in our Algerian Darja, basically. So we had trouble processing all the darja words and trying to understand the real sentiment of the client, because also the client can give us like a mark from 1 to 10 about his satisfaction, but still he can be ungrateful about the service. We have a lot of clients that are unsatisfied, for example, and then they don't want to leave GZ. They like GZ, they like the brand, but they have a problem in their network or something like that. So they have a frustration. But when they are asked to give a mark from 1 to 10, they usually give a good mark because they just like the brand regardless of the problems that they are having. So we needed to put in place the sentiment analysis solution, where we analyzed the comments and the feedback from clients in order to be able to understand their real emotions and their real sentiments. Also, we have fraud detection, where we try to detect in real time fraudulent behaviors. So we have a lot of clients at GZ, and some of them use the network in a suspicious way in order to have a like material gain or any or to make basically have an impact on our network or something like that. So we needed a system in place where we can monitor our network in real time, and then detect frauders and block them from the network. So blockers can use many technologies, and mainly they use technology called SIM box, where they place many SIM cards in this SIM box, which is a box that contains a lot of SIM slots, and they do fraudulent actions with this device. Also, we have rotational client detection, where we have like clients who frequently switch SIM cards, and this is damaging for GZ because these clients already like the service of GZ and they want to stay with GZ, but they keep switching SIM cards to profit from the discounts that they get when they buy a new SIM card. So basically, every time a client buys a SIM card, the seller or the person who sold him the car get the SIM card get a commission, and this commission can vary from price, but they can be big amounts, and they can cause us a lot of losses if we let clients just switch from SIM card to another frequently without controlling them. So we want to control client and give them the bonuses and the advantages of a new SIM card, and the discounts of the new SIM cards without them having to buy a new SIM card. So this will allow us to lower the commission costs when doing our marketing campaigns, and for the sales team, it will be a huge win because they can like market and sell more SIM cards for lower cost. Also, we have network congestion detection and prediction, where we monitor the network in real time and try to identify equipments and connection links that are congested or they are exerting an anomalous behavior. Also, when after detecting these abnormal behaviors in the network, we try to predict using our prediction models. We try to predict whether these events will occur again in the future or not. So basically, these are just few use cases of data science at GZ, but there is more to that. So as you can see, we deal with problems from different fields, from marketing to customer care to network. So really, data scientists should be a versatile person who can work with many people with different mindsets and with different skill sets. So how all of this is possible? How we start from the idea that or problem presented by a business team or marketing team or network team, and then we end up with a model, with a deployed model that can help us optimize our business or our processes. So first of all, we start by a business understanding. So I think this chart is taught in school or in universities as the standard life cycle of a data science project. But the problem here is we don't give weights to all of these steps. So these steps have vary in importance when it comes to a good or a successful data science project. So, for example, business understanding is a very crucial part because it defines which path we should take forward in this project. Because if we don't understand the business right, we will prepare the wrong data. We will look for the wrong things when doing exploratory analysis, and we will model for the wrong data, and then we will be evaluating for the wrong target, and then we will deploy the wrong model. So the whole work at the end will be drastically different from where the business wants to get. So the business understanding part is very important and is very crucial, and maybe it can be more important than any other step in this diagram. After understanding the business, we need to prepare the data by gathering it from different sources. So the data scientist in his daily work is, of course, a computer scientist before being a data scientist. So he need to know basic knowledge about handling the data, or let's say advanced knowledge when it comes to handling the data and to extracting the data from different data sources. Because in a company we have a lot of databases that they are all aggregated in a data warehouse. So the data warehouse or the big data cluster is like a system where the data is stored in structured way. The data warehouse is not meant to be used for data science purposes because it is organized in a way that makes reporting and descriptive analysis easy. But data scientists, unlike business analysts or data analysts, don't work on descriptive analysis. Descriptive analysis is not the domain of data science. And the data warehouse is made for descriptive analysis. So we can't fully rely on any data warehouse to to build our models. So data scientists should be able to use the raw data from all the different data sources without being cleaned or organized by data engineers. So he has to build his own, like let's say, ETL pipelines in order to gather the data from these different sources and unifying them based on time or based on any criteria that he sees fit for this product, for this project. Sorry. So the data preparation step is involves extracting the data from different data sources, which demands data engineering skills, and it also needs data cleaning and data evaluation. So we need to evaluate the quality of data in order to know which transformations or which cleaning processes we need to apply on the data. So the real world data comes with with a high amount of noise, errors, and some missing data because of technical issues or any problem that can occur during occur during the extraction of the data. So data scientists should be able to understand the data and spot what's missing, and should have a low level of granularity where he can dive deep into every data piece, understand it, and see if it's coherent with other data pieces or not. So and this is a valuable skill for data scientists. Also, we can, after this step of data preparation, we move to exploratory analysis, where we try to explore the hidden patterns in the data. Maybe we can find a simple business rules or a simple statistical description that can describe the target that we want to achieve in an easy way, or at least it can give us an intuition about our data, how it is structured, which will prepare us well to choosing the right model. So the data modeling part is an important part where we leverage all the cleaned and the prepared and the explored and the analyzed data for modeling using different data science and machine learning models, and maybe even statistical models. So after modeling the data, we need to test and evaluate our models. So in this step, we should work with the business teams or the teams that ask us for this model, where we can ask them about and show them the results and try to discuss with them the how good the quality of the results and how good the results are. So usually we will have our own KPIs to measure the data, but they are not enough, since the business teams can have strict specifications about how the results should be, how the results should be organized, what level of error they accept. So all of this, the evaluation step is not just the standard like accuracy metrics or AUC metrics that data scientists have, but also it's a discussion with the business team in order to be able to evaluate how well this model will impact our business. So after validating the model with the business teams, we go into the deployment step, where the deployment step is very crucial. And in most cases, a data scientist is not always responsible for deploying the model, but the deployment step necessitates a high level of awareness, where we need to make sure that the model will run in a good environment, where we can constantly change and tweak the parameters of the model to react with the changes in the real world. So as you may know, consumer behavior and any behavior that is external to the company changes over time, and the model should accommodate for that. And during the deployment step, we should make sure that the cycle will continue seamlessly. So after deploying the model, the cycle will start again, and the discussion with the business teams about the problems and the new behaviors will start all over again, and we will follow the steps from the first until the end again. So this is the perceived vision about data science is generally a technical guy who, or data scientist is technical guy who knows all the technologies, or all the query languages and all the tools needed for data science. But there is much more to that. The crucial part, or the hidden part of the iceberg, is a large amount of soft skills, because the data scientist communicates with other teams in order to leverage the data and to understand it. He needs a very low level of understanding of each business and each team's tasks. So for example, if you are working on let's say a churn prediction model, you need to have a low level of granularity of each idea that constitute this churn behavior. So for example, you need to understand the dormancy, meaning how clients go dormant, how clients a dormant client is a client who doesn't exert any behavior. But what does that mean? You need to define it well with the marketing team or the experts that have been working on this problem for years. So you need to communicate with them. Basically, their knowledge is and the data that they have in their minds is what gives the data saved in the servers and stocked in the servers meaning. So you need to communicate well in them, ask them questions that they never ask themselves, in order and help them answer these questions in order to be able to extract their expertise, their knowledge, and apply it on the data to give it meaning. So because without the experience of these people, the data has no meaning. So there is a human element to it. You need to communicate well with people, you need to ask the right question, and you need to help experts express their expertise in a structured way that can be used during the modeling of the problem. Also, you need to communicate well with teams when evaluating the how the quality of the model in general, because as you may know, data science can have a big effect on people work and daily life. For example, there's a good example that I like to give. We have been working on identification problem where we had like agents who used to compare the ID card of clients with their contracts, and if they find any incoherent information, they basically block the SIM card of the client until he provides the right documents. And we had a lot of clients buying SIM cards in daily basis, so it was a huge pain for these agents to quickly identify all the clients, and they have a big backlog that grew over the days. So they needed an automated solution in order to help them and relieve some of the workload. So we tried to build an OCR, optical recognition model, optical character recognition model, in order to extract the information from the scanned photographs of the ID card and the contracts of the clients, and then try to compare this information and spot the incoherent informations and decide whether to block this client or not. uh, the problem was solved seamlessly, and the model was evaluated to be really performing well. But the issue was that the problem was too fast. So having a really fast model in this scenario will lead to big problems, because it can manage all the backlog of daily subscriptions in few hours, and it will leave no work for these agents. And basically, if we deploy a model like that, the agents will have no work to do, and maybe they will be fired in the future. So if we present the model with this level of speed, they would reject it and try to criticize it in a way that would make it impossible for us to put it into production, because it will threaten their basically their work. So we need to understand this human element, and how our models impact other people's work, in order to be able to tweak our models based on their need and perfectly for their need, and convince them with our solution, in order to be able to move forward with the solution and eventually deploy it to production. So the solution we did for this problem is that we cranked down the speed of this model a little bit, and made it a little bit slower, in order to make it process less documents in one day, and leave some of the workload for these agents. So eventually they were happy with the solution, and we managed to take it to production. So always remember that data science is much much more about the human element, about the communication, about querying. Basically, data science on daily basis make query requests to every database and every technology, but we need to know how to query other people's mind, how to extract expertise from them, how we are going to impact them with our work, and how can we market and story tell our work in order to satisfy our final client and have a successful project. There is also a key element to a data scientist work, where it is related to soft skills also, which is storytelling. So you need basically, data science models lack interpretability. So if we say, for example, let's take client behavior, put it through a machine learning model, and the model will say that this client will churn. The model told us that this client will leave the company, but it didn't tell us why. And often we need to understand why, in order to know which actions we should take. So, and this lack of interpretability in machine learning models leaves the data scientist with an obligation to understand the data, understand the behaviors, and not just use the models as a black box, in order to be able to interpret the results of the models and later make presentations to the teams in order to convince them with the results of the model. And here we have the important skill of storytelling. You should be able to tell the story from start to an end. For example, in case of churn prediction, we should tell a story about the client from the moment he enters the company until the day he decides to leave. So it's crucial part and important part of data science job. And the most important part is the human element. So data scientists should be able to communicate with humans, to query their minds, to help them ask the right questions and answer them with them in order to extract their expertise, because their expertise is the key to unlock the data stored in the servers. And without the human element, the data and all the big data and the ocean of data that we have and the exabytes of data generated by human beings every day is meaningless, because it's the human element that gives it its meaning and its value. So this was our talk for today. Thank you everyone for your interest. So if any questions, please don't hesitate. The stage is yours. Hello.
Well, I am now seeing the chat. There is no question actually, so
It's okay. So
let's wait
thank
a
you.
little. It's a, okay.
Let me check on
So
social media if there is any.
in the chat, there is no question concerning the actual talk. So I guess I will be wrapping up this talk. Thank you so much, Benaissa, Mohamed, Fayçal, for that insightful presentation. It's been fascinating to see the contrast between academic theory and real-world applications in data science, especially within the telecom industry. I'd also like to thank you all, our amazing audience, for your attention and engagement during this session. Before we wrap up, I'm excited to inform you that we will meet you again with more talks tomorrow, starting from 7 p.m. with the fourth talk, which will dive into end-to-end machine learning decisions. It will be presented by Nariman Hanouni, so be sure to stick around for that. It's definitely one that you won't want to miss. Once again, thank you for joining us, and I hope to see you in the next session. Have a great rest of your day. GDG for once, GDG forever. Thank you. Wow.